We saw that in the shipping capacity problem, we need a helper function to guide our search, whether it's linear search or even binary search. Basically, the idea behind this helper function is to determine, let's say, given a list of weights, given a certain ship capacity, is it possible to transport all this material in the given number of days so that the solution can be seen as feasible? So basically, this helper function will tell us, given a certain ship capacity, are we in the feasible zone or are we in the infeasible zone? And as we discussed earlier, this separation allows us to, let's say, do a search. Now, there are really two parts to this. First thing first, we need to determine, given a ship capacity, how many days will it, let's say, take to transport all the items that we need to send. And if this number of days is more than the target, which is the requirement, then we say that, okay, look, this solution is infeasible. Otherwise, we say it is feasible. In fact, we can again look at a numerical example to sort of understand what this helper function needs to do, and also, let's say, figure out how we can go about building this. So remember, we took this example. We have weights, let's say 5, 2, 7, 4, 1, 4. Capacity of the ship in this case is 8. This will be an argument to the function. And then D is 3, which is again going to be an argument. So essentially, if my capacity is 8, we know this, remember the material has to be sent in order. So I know that on the first day, I can go and load 5 and 2 on one ship, which is package 0, package 1. So that is 7 kgs. I cannot load 7 anymore because that will exceed the capacity. Remember, the capacity cannot be exceeded. So that's on day number 1. Now, the moment I look at, let's say, item 2, which is 7 kgs or 7 units, I know that I must push it to day number 2. And that's because 5 plus 2 plus 7 is more than, let's say, 8. Now, likewise, 7 can be sent on second day. Now I move to, let's say, 4. I know that 4 and 1 can be sent in. 4, the next 4 cannot be sent in because that will be 9. 4 plus 4, 1 plus 4 will be 9. Hence, I say 4 and 1 on day number 3, which is 5 kgs or say 5 units. That's package number 3 and package 4. And then finally, the last package on day 4. So basically, what exactly are we doing? Let's think through it from a code point of view. We are going through this list item by item, and we are trying to see, okay, how many items can I add before I exceed the capacity. So, for example, in this case, 5 plus 2 is 7. That's fine. But the moment I go and add 7, basically I have to push this to the next day. So that's exactly what we are going to do in our code. We will write a for loop that will basically iterate over this list. Given a capacity, we'll try to find out how many days it takes by just using this logic that the moment I go over capacity, I must then ship on the next day. And if I find that my number of days that I need to transport all this becomes more than this constraint here, then I declare that, look, this is not feasible. Now, one observation which is kind of interesting here is that, look, if the capacity of the ship is smaller than any of these items. So for example, if I look at, let's say, a capacity with 6 units in this example, no matter how many days I have to, let's say, available, in fact, the solution remains infeasible because there is no way I can send, let's say, 7 units on a ship that has a capacity of 6 units. So that's a condition we'll use to, let's say, prematurely declare the solution as let's say infeasible without having to do all the calculations. So that's kind of saves some computation, right? With this background set, I am back to write my code. So I've defined a function called can be shipped. Weights is the list, which is an argument. Ship capacity, is again an argument, and D is the number of days. Basically, the idea is that given a list of weights and a ship capacity, return true if the shipment can be completed within D days, else return a false. So we'll just basically whatever we just sort of did manually with that list, we will have the code do it, and then it becomes scalable. So I will, start with the variable called days. Like how many days do I need to transport all of this? I start filling up my ship with a ship load of 0. And I just define a variable n, which is length of the weight. So remember, I need to run a for loop for all the weights because every weight has to be transported and in the given order. So I just go and say, well, for let's say I in range n. So essentially, I just want to go over every weight. If I find that weights I is, let's say, more than ship capacity. So basically, I just ran into a weight which is more than the ship capacity. Remember, if this situation happens, no matter how many days I have, to, let's say, transport this, I cannot meet the order because the ship cannot carry that specific weight. And hence, I can immediately return a false. Now, basically, so this is like the extreme scenario. But if I do not have this, now this is an elif because I'm just checking for every weight. If elif else, I'm going to have to do one of the three. If I find that ship load plus weights I. So basically I'm starting to load this ship and I find that ship has already been loaded to a certain level. Now if I go and add a weights I to this, if that becomes more than the ship capacity, well, it means that I need to push this to the next day. It means that this particular day is the ship is already too full. So I just have to do days plus equal to 1, which is days is equal to days plus 1. And the ship load then will become weights now this is basically saying that look, at item number 2 the ship capacity was being exceeded, so I'm just moving to the next day and my ship load has been accounted for this particular weight. And finally, if I find that look, ship load plus weights is less than ship capacity, well, I can just go and load the ship. So that's ship load plus equals to say weights I. So basically the ship can be loaded, and you can imagine that this for loop runs for every weight. If L fails, so one of the three conditions happen, and the ship load keeps getting incremented. Also, the days keeps getting incremented. It's a very nice piece of code, very beautifully contained. Now, if I find that while the loop is running, as the loop is running for, let's say, I in this range, if I find that at any point days has become more than D, right? So if that condition has happened, well, that I know is an infeasible solution. So I can just go and return a false. So, if this is, let's say, false. Otherwise, if the entire for loop, let's say, gets over, I can return true because basically, let's say, true. So this is basically the, let's say, um, the helper function that we are going to use. Uh, let's run this once and kind of get a feel for what's going on here, right? So let's say I, use the same so can be shaped. Let's say I use the same list of weights as I was using in the example, and let's see basically how it works, right? So if I say, for example, 527,414, ship capacity of, let's say, 8, and say in 3 days. If I were to do this, well, it tells me false. It tells me that this is not feasible. In fact, we can get more insight into how the program is working by keeping track of how the ships are being loaded. So for that purpose, I've introduced a new variable called iprev. So essentially, when I exceed the capacity, I just write down, so I start with 0. I just know how many items were loaded on the ship on that particular day. And then I move my iprev. Basically, like for example, so notice that at the ith item is where the ship capacity was increases, which means all the items until I minus 1 were in fact loaded. So I can slice this list to print, let's say, what was done previously. Remember when I slice from I brief to I, in fact, I'm not going to touch I, it will be until I minus 1. Then I update my I previous, and finally at the last day I just write down all the ships that have been loaded. So that's kind of creates an interesting insight. For example, let's say my capacity is say 12. So I when I run this, basically, it tells me that first day I load 5 and 2, so that's 7. Next day I go and load 7, 4, and 1. So remember again, that's 12. Third day I load 4, and hence this is feasible. So let's try. Let's say, for example, what happens when I make it, say maybe 16. So when I do this is again true. So first day I load 5, 2, and 7. So that's 7 plus 7, 14. Um, I can't load 4 anymore, but I can do it on the next day. So this creates kind of more intuition into what's going on. But basically, this is just formalizing what we were doing mentally. And given that now we have a program, in fact, we can run this like over much longer lists. So this helper function is what we will use to facilitate our binary search. In fact, this will be crucial because, like I said, the key point here is the feasibility infeasibility split. Below a certain capacity, this is not feasible. Above a certain capacity, it is feasible. The minimum of that is what we are looking at. I hope you found this interesting. At Vybyte, we work on interesting problems, look at their solutions in a systematic step-by-step manner, and build them slowly, again in a logical step-by-step manner. Look at our website, www.vybyte.in, for a lot of material on algorithms and programming in general. Take care. Thank you so much. Bye-bye.